In order to kind of show you what, like this slide is saying, that when a covalent bond forms, that electrons are shared and those actually atoms kind of double dip on those electrons, I want to pick on the compound carbon dioxide and give you a sense of kind of what's ahead, what we need to talk about. So carbon dioxide has a carbon in the middle and oxygen on either side of it. Now, what's important in kind of looking at how electrons are shared are the valence electrons. And hopefully you would say, how many valence electrons does carbon have? Well, it's a 4A, so it has 4 valence electrons. How many valence electrons do the oxygens have? Well, oxygen is 6A, so we're looking at 6 valence electrons. Okay, so I'm going to go ahead and put those electrons around those atoms and kind of show you how this carbon dioxide molecule kind of does its thing. So let me go ahead I'll pick on the carbon, and I'm going to go ahead and make its symbol for electrons. I'm going to make them X's. And I'm going to arrange them this way. I can, just to kind of, you'll see here in a minute why that is. And for the oxygen, I'm going to go ahead and make those little dots. So I'm going to have to put 6 dots around the oxygen atoms. Okay, those are the valence electrons. 6 dots around this oxygen atom. Okay. Now, we talked that there's an important thing that goes on with regard to ions, and actually the same thing comes when electrons are formed, when electrons are shared, covalent bonds are formed. Atoms are looking for what we call a complete octet. We call this the rare gas configuration. That's like our group 8A elements config, okay? So in lining up the atoms as I've done here for carbon dioxide, I'm going to draw a circle around the electrons. I'm running out of colors here. I'm going to pick blue again. I'm going to draw a circle around this first oxygen atom, okay? And as I've drawn a circle, can you see how many electrons it has possession of? Well, I'm getting 2, 4, 6, 8. I'm getting 8 electrons, okay? Why? Well, because 2 of those electrons are from carbon. Carbon shares it. We could do the other side, the other oxygen, and guess what? It has 8. It had 6, but it's sharing 2 of carbons. It's so cool. I just think this whole sharing thing is wonderful. Let me pick, I'm going to change my colors to kind of well, you'll see an orange color here. Now I'm going to draw a circle around the carbon atom, okay? So that carbon atom now has 4 electrons it brought, and it has 2 electrons from each of the oxygens. So guess what? Now it has 8 electrons. Now that is so cool. So that is the sharing of electrons. One more thing I want to show you, and this will make sense soon in this part of lecture, but I'm going to go ahead and draw that structure as we would see it. We would see carbon, oxygen, oxygen, and because we actually, do you buy this? We have 4 electrons being shared here. 4 electrons means 2 chemical bonds, and so 2 chemical bond, each chemical bond is a line. So 2 chemical bonds would be 2 lines. And then I need to account for these, what we call actually just kind of what we're going to call lone pair electrons here, and these 2 lone pair electrons here and here. So this down here, and this will make more sense later, but I'm just kind of giving you a heads up to how this works. This is called the Lewis structure of CO2. Okay, and so that's kind of what's happening behind the scenes. I just thought that was kind of important to show you. So it's all about it, like 8 electrons, and this slide actually shows you all rules were meant to be broken. And the thing about boron is if you have boron, and I don't think we have any in the examples that I show you, if you have boron, it doesn't want 8, okay? It wants 6 around it in the final structure when it bonds with other things. And then we do... you won't have any of these either, but in my general chemistry, not introduction to general chemistry, we actually do this a little bit, where atoms can have an expanded valence, and instead of 8, they want 10, okay, electrons around their final structure, or they want 12 electrons around their final structure, okay, but you don't have to worry about that for this class.